Okay, so we're going to look over how we do vector component addition, how we find vector components. That's what we did yesterday when we found all the x's and y's in that problem. Okay, so that's finding the vector components, and then look at how we add them together. Okay, which we've done already. We did one whole problem yesterday at the end of class there. Okay, where we went through and we found all the x's and y's. We added them together. We got our resultant, and we solved for the whole thing. We're going to look at now the nuts and bolts of that step by step. Okay, so if we have a vector quantity given to us, we know that it has both magnitude and direction, but it can also be broken up into horizontal and vertical components. All right, so if I have this blue vector here, vector A, its horizontal component is this arrow right here that they've labeled AX. It's the X component because it deals with the horizontal or X axis. Similarly, it would have this vertical component that would run on the y-axis. So we would call that its y component. In most of the questions we do, the x-axis will equate to east and west, and the y-axis will equate to north and south. All right. So what we're looking at here is how do we solve for these sides? How do we break this vector up into its vector components, its x and y components? In other words, I want to figure out how far horizontally I go and how far vertically I go while following the blue arrow. Right? That's what we're doing when we solve for the vector components. Right? Now, yesterday, we learned that if we want to solve for x and y, we take what's now the hypotenuse of the triangle and we use it in a trigonometry calculation. Right? So AX, is it adjacent or opposite to this angle here? It's adjacent. Okay, so to solve for this, I'm going to use the cos of theta equals adjacent, okay, over hypotenuse. And then for this one, it's opposite that angle. So for this one, I would use the sine of theta equals opposite over hypotenuse. Okay, and obviously we would know what theta is, we would know what the hypotenuse is, and we would manipulate to solve for the opposite side or the adjacent side for x. Right? That's how we solve for vector components. Okay, so it looks like this. Okay, so we have AX would be A, the hypotenuse, times the cos of theta. That will calculate this side. Okay, and for the y component, because it's the vertical part, well, it's the opposite side, okay, it would go A times the sine of theta. Now, is y always going to be the opposite side? Not always. Okay, it all depends on how you draw the triangle. Yesterday, okay, in one triangle, y was the opposite side, but in the other triangle, it was the adjacent side. It all depends on how the triangle gets drawn. Okay, all you have to determine is that side opposite or adjacent, not whether it's y or x. Okay, questions on finding the sides of a triangle? Hopefully that's like review because you've done trigonometry before. Okay, everybody okay with that? All right, so if we have this vector here and it's 175 meters and is 50 degrees above the x-axis, okay, we would calculate x and y, okay, using trigonometry. So to calculate y, okay, we saw that in that triangle there, y is the opposite side. So I would take the hypotenuse, 175 meters, multiply by the sine of 50 and find that y is 134 meters. And then to find x, okay, it's the adjacent side, so I would go 175, the hypotenuse, times the cos of 50, and find that that adjacent side is 112 meters. Okay, if you're given a 45-degree angle, what's the relationship between x and y? They're the same. Okay, save yourself time. Sometimes on a quiz or a test, I will use a 45-degree angle to save you time. But you have to recognize that I'm trying to save you time by realizing I only need to calculate x, y and x are equal because this is a triangle where those two sides are the same. All right, so just be on the lookout for things like that. Okay, questions on that calculation? Okay. All right, so what we did yesterday was what this diagram is trying to show. Okay, we had two vectors, A and B. Right? And we needed to add them together to find out what the total displacement of the object was. So we drew them first, tail to head. just like they've done here. Right? So they drew A, and then they drew B on the head of A. Then we drew in their X and Y components, which I drew with hashed lines, but they've drawn them solid. All right? So they've got the X and Y components for both. And then we said, good, since we know what B and A are, and we know what these angles are, we can calculate these 4 components. These 4 components will add up to make the triangle for the red vector. Right? So that's what they're showing here in the second one. If I take AY, put it here, and BY, put it here, that's going to equal the side for the red triangle. Okay? If I add those two together, I would get this side right here. Same with the x's. If I take AX, which is this one, and add it to BX, okay, then I get the bottom of that triangle as well. Okay, now I always say add, and in this one it actually is add. But what if one of them goes back on the other? Yeah, then I would subtract, or I would add, making one of them negative, right? Like I would say west is negative and east is positive, okay, or something along those lines to take that into account. Right? So in the end, as we're always trying to do with vector addition, we're trying to get our resultant vector, which is C, into a right angle triangle, okay, where we know the sides. And then we can calculate its magnitude and direction. So that's what we're using the vector components, X and Y, to do, is to find the big triangle. Hey, is that ringing a bell from yesterday? All right, so this is what we've done here, okay? So I want you guys to write this one down, and I want you to start it. Okay, now this is a little easier than one you would get from me because the drawing is already there. I won't give you the diagram, I would just give you the question and you would have to draw the diagram, but we're baby steps. Okay, starting out baby steps. All right, so the 2 vectors here are A and B. All right, so this blue solid arrow and this yellow solid arrow. Right, those are our 2 vectors. We're going to try and find out what they add up to. They add up to C. Okay, we want to calculate the magnitude and direction of arrow C. Okay, so obviously the first step is draw the diagram, but they already did that for you. Okay, so we don't have to worry about that part. Here's what I don't like about this diagram. They drew A's triangle over here, which I get why they did that. So it's not so busy in the middle. But they drew this angle here. Am I using this 70-degree angle when I'm calculating A and Y, or X and Y? What angle am I using? 20. Okay, because inside of this triangle is a 20-degree angle, and that's what I don't like about it. Okay, is that they did that where sometimes people use the wrong angle. Right, so I have to use the angle that's inside this triangle to do these calculations here. The triangle for B they drew just fine. All right, so now that I've got the diagram drawn, I'm going to find out all of my X and Y components. Okay, so in the blue triangle, X is going to be opposite or adjacent to 20 degree. It's opposite. Okay, so I'm going to use the sine of 20 degrees times the hypotenuse, which they told me was 145 meters. Okay, which means that Y will be the cos of 20 degrees times 145. Okay, so X is going to be 49.593. And that's going to be east. Actually, sorry, it says above the horizontal. So I'm going to just say right. Okay, or probably positive. That might be better. Okay, because they're just referring to the X and Y axis. This is the positive X axis. Okay, for Y, we've got the cos of 20 times 145. All right, so we got 136.255. and that's also positive because it was on the positive y-axis. Okay, now I have to do the same thing for the yellow triangle. I don't have a yellow marker, so I'm going to use green. Okay, so to find x for that triangle there, okay, is x opposite or adjacent in that one? It's adjacent. Okay, so in this one, we're going to use the cos of 35 degrees times b, which we're told is 105 meters. And that means that y will be the opposite side. So sine of 35 times 105 meters. Okay, so the x for that second triangle is going to be 86.011. And that's positive, okay, because it's again to the right there. And then for the y, okay, we're going to have the sine of 35 times 105. And that's going to be 60.226. Okay, these are all meters, okay, and this one is negative because it's down. Okay, where do I go from there? I'll give you guys a few minutes. That's your next step. So give you a little bit more time here to get a bit more ahead of me, okay? And then we'll go through the next one. Okay, so our next step here is that we need to put in the x and y components for C, okay, because they're not on here. All right, and then we need that angle, and C is going to represent displacement on this particular question. All right, so to get red x, I've got to take the two x's, okay, ax here and bx here. They both point to the right, okay, they're both positive, so I just need to add them together. So I'm going to take my 49.593, and I'm going to add that to my 86.011. But obviously with all the decimal places, I just haven't written them all. Okay, all of those will end up in there. All right, so we will have, probably quicker to do it this way. Okay, so we're going to get a total there for x as 135.604. And that's positive. Okay, then we need to find y, but since in the first part we went up and in the second part we went down, okay, I'm going to need to make one of them negative. So I'm going to have the 136, which is the y component for A, 136.255, and I'm going to add that to negative 60.226, or just subtract them, whichever. It doesn't really make much difference. Okay, so we're going to have the cos of 20 times 145, okay, minus the sine of 35 times 105. Okay, so we're getting then that what's left here as red y is 76.03, we'll say. Okay, and that's also positive. It's still above the x-axis. Right. Okay, so now I've got the x and y components of my resultants. I need to find the magnitude of my resultant and the direction of my resultant. So how do I first find the magnitude of my resultant? Right, Pythagorean theorem, a squared plus b squared. Okay, so we'll have that the total displacement is going to be the square root of our 76.03 squared plus 135.604 squared. Okay, and again, we want to use all those decimals, so 135.6038854 squared plus 76.0299.042 squared. Okay, so my total displacement, or the magnitude of my resultant, is 155.46 meters. And now I need to find its direction. Okay, so I need to find theta now. All right, so I will use those two sides again in a trig calculation, tan to the minus 1 of the opposite side, which for me is 76.03, over the 135.604. Okay, divided by our 135.6038854. All right, so I'm getting an angle there of 29.36 degrees. Okay, now I need to look back here, and I have how many significant figures for this question? 3. Okay, every single number I was given has 3 significant figures. Okay, so I'm going to put these two into that format first. That'll be 155 meters at 29.4 degrees. And now what do I need to determine about that 29.4? I need to give it a direction, right? 29.4 degrees. What they told me was above the horizontal or from the horizontal. That's what they gave me in the questions. So for me, that angle is, I can't give north of east because they didn't actually tell me north and east, right? They referenced the x-axis. They said above the horizontal, okay, and below the horizontal. So this angle here would be above the horizontal, right? So unless we're actually given compass directions, we don't default to them. Okay, we have to go with what was given in the question. So this would simply be above horizontal. And that's something that does catch people because everyone wants to put the compass directions in because we use them so often. But if a question doesn't specifically state compass directions, you have to go with what it states. Okay. Did that make a little bit more sense today than it made yesterday? You would not, because somewhere along the way you rounded when you shouldn't have. Got to keep all those decimals all the way through. Okay. Any other questions on that one? All right, so we've now done 2 examples. Okay, kind of walked through them both. All right, now we're going to see how we do. So this is all the work we just did. So it's just the notes for explaining everything we walked through with that question. All right, so we'll just kind of skip through that here. All right, that one we're not going to do. Okay, I want you guys to do 1 and 3 here. This is just vector components. It's not a big long question like we just did. It's just finding x and y. But we're not going to do number 2 because number 2 uses the rectangular coordinate system, which makes no sense at all. Okay, nobody says that Calgary is 90 degrees from here because that's dumb. So we won't use that. Okay. All right. Okay, so in order to do number 1, we just need to draw it. Okay, it's a single vector, and they only want to know what's the north component of this person's displacement. So it's 15 kilometers long, and it's angled 40 degrees east of north. So I draw my reference line to the north because that's where the angle is measured from. I go 40 degrees east of that and draw my triangle. This side's 15 kilometers. This angle is 40 degrees east of north. Okay, and I am looking for this side. because that is the north component, or how far north he goes in doing this. So that is adjacent to the 40-degree angle, right? So that means that y is going to equal the cos of 40 degrees times 15, right? And when we do that, we should get 11 kilometers north. Did I lose you? No? Okay. How many people have done number 3? Okay, let's have a look at 3 as well then. All right, so snowmobile travels 65 kilometers, 37 degrees east of south. Similar thing. First thing I want to do is draw that vector. The reference vector is south. Okay, it's 37 degrees east of south. Okay, and it's 65 kilometers. We're looking for how far east. That is the x component for this one. So to get that, it's the opposite side. So x will equal the sine of 35 degrees times 65 kilometers, okay, which should give us 39 kilometers east. All right, questions on those two? Okay. All right, I want you guys to try number 2 right now. I'll make it bigger so you can see it. You don't have to do number 1 because that uses that rectangular coordinate system that we're not going to use. Okay, so number 2 is very much like the ones that we have done yesterday at the end and today at the beginning. Okay, it's just like those ones. So draw the 2 vectors, tail to head, draw their x's and y's, find their x and y's. Okay, go on from there, follow those steps we learned yesterday. Let's see how we do with that one. I'll give you about 5 minutes or so, and then I'll draw the diagram just so you know whether you've got that right, and you can kind of go on from there. Okay. So I'm going to draw the diagram here, guys. On one like this, scale is important, okay? I mean, the 2 lines are about the same length. That part's not so crucial, but the angles are crucial, okay? So our first vector here is 15 meters long, 15 degrees north of east. So I'm going to draw myself a reference line, okay, that's due east, and then I'm going to go 15 degrees north of that. So it's a pretty shallow triangle, okay? That's probably too shallow. All right, so let's say that that's 15 degrees, okay? So that means that this is y, and this is x, and this is 15 kilometers long. All right, my next vector is 13 meters, 5 degrees west of north. So I'm going to draw myself a reference line that's north, okay? And I'm only going to go 5 degrees west of it. So here will be x, here will be y, this is 13 meters, okay, and this is 5 degrees in there. All right, so that's what the 2 vectors should look like, which means that our resultant will look like that. Okay, so hopefully your diagram looks like that. If it doesn't and you're not sure where you went wrong, let me know and I can come give you a hand.